So this is paper one, May, June 2020, and paper 1-2. Move to the question number one. Look, the question number one is, what is the reasonable estimate of the mass of the raindrop? So the mass of the raindrop is very, very small. So we have to select here the smallest value of the mass. So 10 power 1, 10 power minus 1, 10 power minus 3, 10 power minus 5. So this is the reasonable estimation. Next, question number two is, which quantity is a scalar? Yes, kinetic energy is a scalar because acceleration vector, force vector, and the momentum vector. Next question is, a galvanometer of resistance 5 ohm is to be used in the null method in order to protect the galvanometer from damage due to the excessive initial current. Yes, so the very small current is required through the galvanometer. So the galvanometer is protected by connecting it in series with a high resistance and very small resistance parallel to the galvanometer. So when the resistance of the small resistance is 0.5 and this is 5 ohm, so the large current will pass through the small resistance in parallel, less current through the galvanometer. If the high resistance is connected in series, then definitely a small current will pass through the circuit. So whenever we have to protect any device from the large current, so the high resistance must be connected in series and the parallel small resistance parallel to the device and the high resistance in series. So high resistance will reduce current and the small resistance will get large current. So the small current will pass through the galvanometer. So which arrangement would provide this protection? 0.5 resistor in series, no. The 0.5 resistor in parallel, yes. And this combination placed in series with 1 kilo, so B is the answer. Now the next is, a reading are made of the current I for the different voltage V across the fixed resistor. The results are plotted on the graph to show the variation of I and V. What is the best description of the error? Look, this is a straight line. All points are exactly on the line. No scattering of the point, so no random error. But when the voltage is 0, current is not 0, it means the ammeter has some 0 error, and 0 error is a systematic error, so D is the answer. Next question is, a stone is dropped from the height of 20 meters above the water. The graph shows the variation with time t of the velocity of the stone. Which statement describes the approximately position of the stone 4 seconds after it is dropped? Look, this is the level of the water. Stone is dropped from the height of 20 meters. In first 2 seconds, area under the graph is the distance covered by the stone, falling stone, half base into height. So answer is 20. Mean after first 2 seconds, the stone reaches the surface, the level of the water. And in the next 2 seconds, distance covered be length into width, it is 10. So it will cover further 10 meters below the water surface, mean into the water. So which statement describes the approximate position of the stone 4 seconds? It is at the 10 meter above the surface of the water? No. It is at the distance of 10 meters below the surface of the water? Yes. After 4 seconds, it reaches here, which is below 10 meters, the surface of the water. So B is the answer. Next question is, a car X is traveling at the constant speed U along the straight road at time 0. The second car Y is at the distance of D naught. This D naught is the gap between the two cars behind the car X, and the traveling at the speed V in the same direction. Speed V is less than speed U. At time 0, the car Y begins to accelerate with uniform acceleration. Car Y overtakes at this time, capital T. Look, the gradient of distance time graph is speed velocity. So the velocity of the v after t0 is increasing. So the gradient must be increasing. So at d, the gradient constant, so wrong option. Here, the gradient is increasing, then decreasing. No, this is a wrong option. Now, the match between B and C. So initially, the speed V is smaller than U. When the car Y is slower than car X, then the gap will the car Y is moving slowly as compared to the car X. So initially the gap will increase and then the gap will decrease with the increasing speed. So initially look, the gap is increasing and then the gradient is increasing. So B is the answer. So here, initially the gap is not increasing, it is decreasing. So C is the wrong answer. So B is the option. Next, simple question. The resultant force acting on the object is slowly increased. Which graph could show the variation with time t of the momentum p of the object? Look, force is equal to change of momentum divided by time. So change of momentum divided by time is the gradient for the momentum time graph. So when force is increasing, gradient must be increasing. So here the gradient is decreasing. Here the gradient is decreasing. Here the gradient is constant. So B is the only option in which the gradient is increasing in the opposite direction. So B is the answer because the gradient is increasing. The line is becoming more steeper. Next, question number 8. An astronaut has a weight of 660 Newton when she is standing on the Earth's surface. The acceleration of the free fall on the Mars is 3.7. What would be the weight of the astronaut if he stood on the surface of the Mars? Look, weight is equal to mg. Mass will remain same on both planet Earth and the Mars. So the weight directly proportional to g. We can write W1 over W2, G1 over G2. Weight on the Mars required. Weight on the Earth is 660 and the G on the Mars is given 3.71 and the G of the Earth is 9.81. So the weight on the Mars will be 3.71 times 660 divided by 9.81. So it's approximately close to the answer C. So 250 Newton. Yes, next question is 9. A mass m traveling with the speed u1 collides with a mass m2 traveling with the speed u2 in the same direction. After the collision, mass m1 has a speed v1 and m2 has a speed v2 in the same direction. The collision is perfectly elastic. Yes. Number 1, this collision will obey the law of conservation of momentum, which is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So we can write it m1 u1 minus m1 v1 is equal to m2 v2 minus m2 u2. When m1 is taken common, it becomes u1 minus v1. So m2 taken common, v2 minus u2. So look, this equation is written here and we have to choose which is incorrect. So this is correct. So C is not the answer because this equation is correct. Now, move to the next. Due to the perfect elastic collision, velocity of separation is equal to the negative velocity of approach. So it can be written as, when this minus sign multiplied here, it becomes minus v1 plus v2 is equal to u1 minus u2, or it can be written as v2 plus u2 is equal to v1 plus u1. So this equation is also written here. So this is also correct. So B is not the answer. Now move to the next one. For perfectly elastic collision, total kinetic energy before collision is equal to total kinetic energy after collision. So we can write half m1 u1 square plus 1 by 2 m2 u2 square 1 by 2 m1 v1 square 1 by 2 m2 v2 square. Total kinetic energy before collision, total kinetic energy after collision, so half cancelled. It becomes m1 u1 square plus m2 u2 square m1 v1 square plus m2 v2 square, which can be written as m1 u1 square minus m1 v1 square is equal to m2 v2 square minus m2 u2 square, and it's written here. So definitely this D is the answer, because this equation is not valid for this interaction. So D is the answer. Move to the next. Question number 10. The diagram shows a negative electric charge situated in the uniform electric field and the mass in the uniform gravitational field. This is electric field. An electric field is directed from positive to negative charge. It means if two plates are placed here, so this must be connected with the positive, this must be connected negative. So this negative charge is attracted by the anode plate. So this is the direction of the force. Which row shows the direction of the force acting on the charge? So either this, either this. Now move to the next. This is the gravitational field. And the gravitational field exert force on the neutral object, and that force is called the weight. Look, if this is the direction of the gravitational field, then the object falls down due to the weight. And here the gravitational field is drawn horizontally, not vertically. So definitely the mass will fall horizontally along the field. So this is the option for this. Move to the next. A bicycle pedal is connected to a pivot by a metal bar as shown. What is the moment of this force? Look, this is the line of action of the force, 60 Newton. And the moment is force multiplied by perpendicular distance. So the perpendicular distance is 16. So we will write force is 60 multiplied by its perpendicular distance from the pivot, 16 divided by 100. So the answer is 9.6, because weight, this force 60, and this perpendicular distance. So answer is 9.61. Okay, move to the next. The question is, a thin horizontal beam XY is freely hinged at the point Y to the vertical wall. The beam is held stationary by the cable XY, which is attached to the wall at the point Z. The beam supports the weight W at the point X. The force in the cable and the beam FC, FB respectively, which vector triangle represent the forces acting on the X. So beam supports the weight. It means equilibrium position. In equilibrium, all forces must be directed in one direction. So look, force in this direction, weight in this direction, it's not the answer. Then this FB in this direction, FC in this direction, not the answer. So all forces are in one direction, anti-clockwise, clockwise, and all forces in anti-clockwise. So we have to select one answer. Look, weight acting downward, and here weight acting upward. So this is the wrong answer. So A is the correct option, because the weight directed always downward. The pipe open at one end flows in a liquid as shown. The cross-sectional area is given. The weight is given 32. What's the density? Look, when an object is floating, two forces are acting. One is the weight and other is the upthrust. Weight is equal to upthrust formula rho GAH. So the weight is given, which is 30, rho G value 9.81, area is given, which is 0.012, and the depth of the liquid, not the depth of the tube, because the upthrust exerted by the displaced water. So it is 0.30. By calculating this, 32 divided by 9.81, 0.012 divided by 0.30. This is the density, and the answer will be approximately 910. Okay, during an interval of the time, the fuel supplies energy X to the car. So this X is the input energy. So input energy is equal to the last energy plus output energy. Some of the energy is converted into the kinetic energy as the car accelerates. Mean the kinetic energy is the output energy. The rest of the energy Y is lost as thermal energy. What is the efficiency? So input energy is X. And what is the output energy? Output energy is equal to input minus last. This is the output energy. So input is X and the last is Y. So the output is equal to X minus Y. So efficiency is output energy over input energy. So the efficiency will be X minus Y output divided by input X. So the answer is C. Now move to the next question, number 15. In which situation is the work done on an object? The object slides with a constant velocity along the horizontal frictionless surface in a vacuum. An object slides with a constant velocity along the horizontal frictionless surface in the vacuum. Number 2, a person holds the object at the arm's length and at the fixed height above the ground. The person pushes the object up the frictionless ramp. The stationary object floats partially submerged in the water. Look, the stationary object, no distance covered, no work done. A person pushes the object up the frictionless ramp. So yes, the force is exerted in the direction of the distance covered. Yes, work is done. A person holds the object at the arm's length and at the fixed height above the ground, no distance covered, no work done. The object slides with a constant velocity along the horizontal frictionless surface in a vacuum. So the force acting down, because the horizontal surface, the weight is down and the distance covered in the horizontal direction. So the weight and force, the distance and the force not in the same direction. So the no work is done by the force. So C is the option. Now question number 16. A spring is attached at one end of the fixed point. A mass M is then hung from the other end of the spring. The spring has extension X with a system in the equilibrium. The variation of the tension in the spring with the extension is shown. Which statement is correct? The area, tension and extension mean force and distance graph is the elastic potential energy, strain energy. Area SPR, SP and R represents the energy stored in the spring which cannot be recovered. No, the area under the graph. So this is not the area under the graph. So A is the wrong answer. Area SPQR. SPQR is the area, is a rectangular area. But the area under the graph will be triangular area. So this is wrong. Area SPQ. SPQ represents the loss of the gravitational potential energy of the mass due to extension of the spring. No, because the energy is equal to work and the work is done when distance is covered. So for the energy, for the work, we have to take the area adjacent to the distance axis, adjacent to the extension axis. So this is theoretically not the area. This is the area. So area SQR, this area, this one, which is under the line, adjacent to the extension, represents the elastic potential energy. So D is the option. And do remember, energy is equal to work, and work is done when distance is covered. always take the area or shade the area which is adjacent to the extension axis to represents the elastic potential energy. So D is the option. Now question number 17. An escalator in an underground station has 25 people standing on it and is moving with a speed of 4.3 meter per second. The average mass of the person is 78 at the angle of escalator to the horizontal 40 degree. What is the minimum power? Look, the power is equal to force multiplied by speed. And down the slope, the force is Wy into speed. So the component of weight acting down the slope is always W sine theta. So we will write W sine theta into speed. And this W is equal to mg. So we will write mg v into sine theta. So there are 25 people. Mass of the each is approximately 78. The value of the g is 9.81. And the speed is 4.3 multiplied by sine of 40 degree. So after calculation, we will get 53,000 watts. So 53 kilowatts, C is the answer. Now, move to the next. An elastic cord of unstretched total length 16 centimeter, this one, has cross-sectional area 2 into 10 power minus 6, is held horizontally by two smooth pins and the distance 8 centimeter apart. The cord obeys the Hooke's law. The load of the mass 0.4 is suspended centrally on the cord. The angle between the two sides of the cord supported by the load 60 degree. What is the Young modulus? Okay, so look, this is the extension, this one. So this is the extension X for this side and another extension X for this size. So because this is initially 8 centimeter, it extends both sides, this side and this side. So the total extension in the direction of the load is X, and X mean 2X. So first we have to calculate the extension. Look, this is 8 centimeter. So this becomes 4 centimeter. This angle becomes 30 centimeter. So according to this is perpendicular, this is a base. So the perpendicular divided by base is equal to tan theta. So perpendicular is force and the base X is required, tan of 30 degree. And this is approximately X is equal to 6.93. So the total extension E will be 2X. So it becomes 6.93 times 2, approximately 13.85 centimeter, means 0.1385 meter. Now we have to calculate the Young modulus, and the Young modulus is equal to, E is equal to stress divided by strain. So it becomes F divided by A times L divided by E. So F force is given 0.4 times 9.81 approximately, divided by area is given 2 into 10 power minus 6. And the initial length is given 16, mean 0.16, divided by extension is 0.1385. So after calculation, the answer is coming approximately 2.3 into 10 power 6. So 2.3 into 10 power 6 is the C answer. The C is the answer. Now next question, question number 19. A student is investigating the mechanical properties of the metal. He supplies the different loads to the long thin wire up to its breaking point and measures the extension of the wire for each load. He then plots the graph of the stress against strain. The students repeat the experiment with the wire made from the same material same material mean, same Young modulus, and the gradient of the stress strain graph will remain same. So which graph is obtained which has the same gradient as this one? So we have to select the similar graph. So look, which graph is similar to this? It's going up to 40. This is up to 80. This is up to 80. So these two are rejected. Now we will compare the shape. So 10, 20, 30, 40. So here also 10, 20, 40. So at 10, it's approximately, look at the y-axis, 1, 2, 3, 4. And here it is 4, 8, 10, 6. So this is wrong and this is correct because this is the similar graph. At the x-axis up to 40, at the y-axis up to 4, and the shape is same. So this is the graph because the Young modulus will remain same. Now move to the next. Which statement describes what is meant by the plastic deformation of the material, mean permanent deformation? Now, it always obeys Hooke's law. No, not necessary. It does not return to original length when the extension force is removed. Yes, correct. It never obeys, no, but it never obeys Hooke's law. But when the object is in the elastic limit before the plastic deformation, it obeys. So this is wrong. It returns to the original length. No, because it is permanently deformed. So the best option is B. So B is the best option. Now, question number 21 is, a transverse wave is moving along the rope. 2 points X and Y on the rope are a quarter of the wavelength apart from each other. Which statement is not possible for the 2 points X and Y at an instant? Look, this is a progressive wave. All points are moving. No points is stationary. So we have to select the wrong option. They are both stationary. No, all points are moving in a transverse wave because along the rope, the wave is traveling. So this is the wrong option. So this is the answer for this 21 question. Next is 22. The question is, two progressive waves meet at a fixed point P. The variation with time t of the displacement of each wave at the point P is shown in the figure. What is the phase difference? Okay, select any 2 points, similar point. Look, this wave here and the similar point of the second wave is this. So these two similar points of the two waves are at the gap of 0.1, 0.2, 0.3 at 0.3 seconds. Now one wave is completed in 0.8 second. So 360 degrees are represented by 0.3 seconds, sorry, 0.8 seconds. If 0.8 second is representing 360 degree, then the 1 second will represent 360 degree divided by 0.8. And the time difference between these two waves is 0.3. So 0.3 second will represent 360 degree divided by 0.8 into 0.3, and it is approximately 135. So C is the answer. So first we have to select the two similar points. One wave is completed in 0.8 second. So how much angles are completed? How many angles are completed in 0.3 seconds? So 135. So 0.8 second, 360 degree. So 1 second, 360 divided by 0.8, and in 0.3 second, which is the difference between two waves, right? So the answer will be 135. Now the next is, a microphone connected to the Y plate of the CRO is placed in front of the loudspeaker. The traces on the screen of the CRO is shown. The time-based setting is 0.5 and the Y plate setting sensitivity is 0.2. What is the frequency and what is the amplitude of the CRO? So first of all, we have to draw the equilibrium position. Now look, this one wave is approximately completed in 1, 2, 3, 4, 5, and 6 boxes horizontally. So the time period is equal to time-based setting multiplied by number of the horizontal boxes. So time-based setting is 0.5, multiplied by horizontal boxes are 6. So 6 5s are 30. So this is approximately 3 into 10 power minus 3 second, because this is given in milli. Now we have to calculate the frequency. So the frequency is equal to 1 divided by time period. 1 divided by time period is 1 divided by 3 into 10 power minus 3, mean 1000 divided by 3. So the answer is 330, either A, either B. Now, we have to also calculate the amplitude. How many vertical boxes? 1, 2, and 3 from the equilibrium line. So this voltage is vertical gain setting multiplied by vertical boxes from the equilibrium line. Voltage gain setting is 0.2 and the vertical boxes are 3. So the answer is 0.6. So the correct option is A. Move to the next. This 24. Question is, the diagram shows an experiment to produce a stationary wave in the air column. A tuning fork placed above the column vibrates and produces a sound. The length of the air column can be varied by altering the volume of the water in the tube. The tube is filled and then water is allowed to run out of it. The first two stationary waves occur when the air column length are 0.14 and 0.42. So first node at this and antinode at this. But when second loud sound is heard, the gap between the first stationary and second, mean first node and the second antinode. So first antinode to second antinode at the open end, this distance is equal to lambda by 2, and this distance is equal to 0.42 minus 0.14. So lambda by 2. So lambda is equal to 0.42 minus 0.14 multiplied by 2. So you will get this answer 0.56. So first subtract 0.42 and 0.14 and then multiply by 2, because from antinode to antinode distance is equal to lambda by 2. So first calculate the distance between these two and then multiply by 8. So you will get the answer 0.56. Now move to the next. A stationary person measures the speed and wavelength of the sound from the horn on the stationary vehicle. The person then repeats the measurement when the vehicle is approaching at the constant speed, mean it's moving towards the observer. So when the source of the sound moves towards the observer, frequency observed increases, wavelength decreases, and the actual speed of the sound remains same. So the question is, which row describes the measured wavelength and the measured speed of the sound wave from the moving vehicle when so the wavelength of the sound will decrease and the speed of the sound will remain same. So the answer is D, according to the Doppler effect. Okay. Next, the table shows the wavelength of the 5 electromagnetic wave. Which row correctly identifies the principles relation of each of these of the wavelength? Yes, so you have to remember the wavelength of the electromagnetic spectrum. So according to the wavelength of the electromagnetic spectrum, yes, gamma rays has 10 power minus 14, X-rays 10 power minus 10, infrared 10 power minus 6, so microwave 10 power minus 2, and the radio wave plus 2. So you have to remember these wavelength according to their wavelength. So the A is the correct option. Now, two compressive waves meet at a point. Which condition must be met for the superposition of the wave to occur? Superposition, the word. The wave must be coherent. This is the condition for the interference. The wave must be of the same type, yes. And the wave must be traveling the opposite direction, not necessary. The wave must meet in phase, not option. So two progressive wave meet at a point. What condition must be for the positions? Yes, both must be of same type. This is very, very important. So this is the correct answer. The hill separates a television transmitter from the house. The transmitter cannot be seen from the house. However, the house has good TV reception. So by which wave effect at the hill could the TV signal reach the house? By spreading, by bending? So diffraction. Answer is B. Next question is, the diagram shows an arrangement for demonstrating the two sources of the interference using the coherent light of the single wavelength lambda. An interference pattern is observed on the screen 3.0 meter away from the slit X and Y, which has separation of 1 meter. The central bright fringe is at Q, and the second bright fringe is at P. So this is N2 bright fringe. What is the distance between Q and P? Look, the distance between two consecutive bright fringes, lambda D divided by A. But this P and Q distance is double. So we will multiply it by 2. Now the question is, what is the distance between Q and P? Mean this 2x is required. So lambda, not given. This D is 3, multiply by 2, divide by A given, 1 into 10 power minus 3. So the answer is 6 into 10 power this 6. So when you will convert this in meter, this is 3 and this is 1 into, here is written. So 1 millimeter mean 1 into 10 power minus 3. So this answer will be 6 into 10 power 3 times lambda. So 6 into 10 power 3 times lambda. So the option is A. So you have to calculate actually 2x by putting lambda D 2 times A. So this is the option. Now move to the question number 30. Light of the wavelength lambda is incident normally on the diffraction grating. The angle between the second order maximum and the normal to the grating theta, the variation with sine theta of the lambda is shown in the figure. So look, the formula is d sine theta is equal to n lambda, and lambda divided by sine theta is equal to 1 divided by grating times this n is 2. So lambda divided by sine theta is the gradient, and the gradient is equal to this 1 over 2g is equal to the gradient, which is 750 divided by 0.6. And when it is calculated, so g is approximately 400 per millimeter. Okay, you can calculate g by cross multiplying 0.6 times 2g times 750, and then g is equal to 0.6 divided by 2 divided by 750. So you will get answer 400. So this is the option A. Now move to the next, this 31. A dipole is a pair of the charges of the equal magnitude, one negative and one positive. The electric field of the dipole is shown in the figure. in which direction does the force act on the electron when at X? So when electron is placed here, so electron is attracted towards the positive charge, the positive side. But at this point, the direction of the force will be the tangent towards the positive. So when we will draw the tangent, so this is the direction of the force. So D is the option. So this is attracted along D direction at this point, X. So this is the option. Now move to the number 32. So a charged oil drop of mass M is the potential difference is then applied across it. The result is the oil drops continue to accelerate downward, but with the reduced acceleration. So these are the two plates. Weight is acting down and electric force is up. So it is accelerating downward. It means the weight is greater than this. So we can write weight minus upward electric force is equal to ma. And the next situation is the polarity of the applied PD is then reversed so that the direction of the electric force on the droplet is reversed. The result is downward acceleration of 3a. So it means in this case, both forces mean weight and the electric force are acting downward. It means F plus W is equal to 3 times ma. Now, we can write this minus F plus W equal to ma. We have to eliminate this weight, so change the sign. So this is positive, this is negative, this is negative, so weight cancelled. It becomes 2F and it becomes 2ma, so cancelled. So F is equal to ma. And do remember the electric force F is equal to EQ is equal to MA, and then E electric field strength is potential difference divided by D, and this B is given X, so times Q is equal to MA, hence Q is equal to MAX over V, so the correct option is yes, A. So look at this. Next question number is 33. The number density of the free electron in the copper is 8 into 10 power 28. The copper has a diameter 0.42 millimeter. What is the average drift velocity when the current is 0.57? So look, I is equal to NQAV. So V is equal to I divided by NQA. Substitute the values. So it is 0.57 and number density is given 8 into 10 power 28. The charge of the electron 1.6 into 10 power minus 19, and this area is pi by 4 diameter square, and the diameter is 0.42 into 10 power minus 3 and then square. So after the calculation, you will get the answer 3.2 into 10 power minus 4, which is the option. Now move to number 34. An electric kettle is rated at 2 kilowatt, which describes the power supplied to the heating coil in the kettle. The coil has a resistance of 5 kilo ohm. What is the current in the coil? So we have to calculate the current in the coil. So look, formula is power is equal to I square R. So power is equal to I square R. The power is 2 kilo, mean 2000. Current is required and the resistance is given 5000. So the I is equal to 2000 divided by 5000 under root. So after calculation, we will get this 0.63 answer. Number 35. A conductor consists of the 3 wires connecting in series. The wires all are made of the same material but have the different cross-sectional area. There is a current A of the conductor. Look, thicker diameter, so less resistance, and here thin, some more resistance. So voltage drops directly proportional to the resistance because in series current remains same, voltage directly proportional. So here small resistance in number one, so small drop in the voltage, and this number three large resistance, large drop of the resistor, not drop of the voltage. So we have to select the graph. So this A, yes, small decrease, then large decrease, then large. So A is the option. And B here, look, this is dropping, and here gradient is not increasing. And then this is not increasing. Here the small decrease. Look, here the small decrease. So this is wrong. And here no decrease, constant, no decrease, mean constant. So option wrong, C and D. And here, instead of the large decrease of the voltage, large decrease of the voltage, here is a small decrease in the third part of the resistor. So this is wrong. So the only option is A. Now move to the number 36. The question is the maximum power that can be dissipated by the resistor without overheating is 0.5. What is the maximum value of the EMF for the resistor not to overheat? So look, we have to calculate the maximum value. So power is equal to V square over R. So total resistance is external plus internal. So the power times total resistance is equal to V square. So power times R plus R, and whole under root is V. So the power is 0.5, external resistance 4.7, internal 0.5, then under root, it is approximately 1.61 volt, but we have to select the maximum value of the E. So the maximum value of the E close to the 1.61 will be 1.7. So this is the option 1.7, C answer. Number 37, Kirchhoff first and second law linked to the conservation of the physical quantity. The first law, yes, simple, law of conservation of the charges, and the second law, the law of conservation of energy. And number 38, the question is in the circuit shown, X is a variable resistor whose resistance can be changed from 5 to 500. The EMF 12 volt, the negligible internal resistance. What is the maximum range of the values potential difference across output? Look, V1 is equal to R1 over R1 plus R2 into EMF. This is the potential divider formula. So first suppose the X resistance is 5 divided by 5 plus 40 times 12. So 60 divided by 45. And then is approximately 1.3. Then next, V1 is equal to, now suppose this R1 mean X resistor varied from 5 to 500. So this is 500 divided by 500 plus 40 times 12. So the answer is coming approximately 11.1. So 1.3 to 11.1. So the option is A. So this is the variation in the potential when resistance varies from 5 to 500. Next, 39. An unstable nucleus goes through the successive decays to become a final stable nucleus. The initial nucleus and the final nucleus are the isotope of each other, mean they have same number of protons. How many alpha beta particles could have been emitted during this decay? Suppose we have element X with proton number and the mass number. When alpha is emitted, it becomes a new one, Z minus 2 and A minus 4. Now we have to make this Z minus 2 Z again. So beta is emitted first. So it becomes new one, suppose it's P, and this becomes Z minus 1 because one proton increases, mass number remains same. And again, beta is emitted. So it becomes pose T element. So Z and A minus 4. Look, this X has Z proton number, T has Z proton number after the emission of 1 alpha and 2 beta. So 1 alpha and 2 beta mean B is the option. Next, a hadron has a charge of minus E and is composed of 3 quarks. What will be the quark composition of the hadrons? Do you remember? There is no down quark. Yes, up and strange. So up has plus 2 by 3 elementary charge and the strange has minus 1 by 3 elementary charge. So we have to make minus E total. So if we select these strange quarks, 3 strange quarks, so minus 1 by 3 elementary, minus 1 by 3 elementary, minus 1 by 3 elementary. So this becomes minus 3 by 3 elementary. So 3 cancelled, it becomes minus E. So it means this minus E charge is the combination of 3 strange quark. So A is the option. So when 3 strange quarks are added, the final answer will be the minus E. So this is the option.